Hi everyone. In this short tutorial, I want to show you the new method in the graph class called Quotient or Quotient Graph. So you find it under graph.quotient, and I'll explain what that means in a second. So for the definition of quotient graph, in graph theory, a quotient graph is formed by grouping vertices of a given graph into blocks, where each block is a set of vertices, and then creating a new graph whose vertices are these blocks. So basically, in the context of topologic pi, it doesn't have to be vertices. It can be any subtopology, vertices, edges, faces, or cells. And you group them, you take subcomponents or subtopologies, let's say faces of a shell, and if they have the same dictionary key value pair, let's say same color or same ID or same room type, you group them all together and you represent them by a single vertex. And if at least one of them is adjacent to another group or another subcomponent of that group, then you create an edge between the vertices and you go on and you create all of these relationships and you create a new graph. And that can give you some insights into the thing that you are modeling. So here's an example of it. Let's assume you have this kind of ring shape. It's a shell, and it's made out of these faces, as you can see here, and some of them are of different colors. So you can have a dictionary, of course, with a key value pair, and this is here expressed as a color. So, but you can think of those as different room types or different functions, whatever have you. Now, the idea here is that you group subcomponents that have the same dictionary value, like in this case, the same color. So all of the red subcomponents get represented by a single red vertex, all the green into a green vertex, so on and so forth. Even if they are disjointed, as you can see here in the light green, as you can see here in these two, or in the orange, they all get aggregated and represented with a single vertex. So these circles that you see here, the small circles with their outline, are the vertices of the future graph, or of the quotient graph. So then you could also optionally change the size of these graph vertices to represent the quantity of the components that they represent. So as you can see here, there are a lot of red components. So the red vertex get to be bigger. The what is it? The purple one, this color perhaps, or this one, the dark blue, excuse me, this dark blue one has the smallest one, and you can see the relative sizes of the other one. So you could express or visualize the quantity of each component using that. It doesn't have to be quantity as well. You could invent your own way of aggregating that size, like for example by area, etc. The topology, how you draw the edges between these nodes, is based on the original topology. So in this case, you can see here, I put arrows between neighbors, at least one neighbor. And if there is that relationship between at least one neighbor and another neighbor, an edge is created in the quotient graph. And there is a Jupyter notebook on GitHub called Quotient Graph. That you can try, and it is in the latest version of Topologic Pi. As of the recording of this video, it is 0.8.49. Thank you for listening, and see you at the next video.